Woohoo! We are recording, and this is the second video I'm making outside of YouTube, and it's very exciting. Yay! Because we have new technological advancements like turning the camera sideways. This is very exciting. So you're not watching it. I know the first video was it had that kind of foreign film letterbox je ne sais quoi, but this one has full screen viewing. There we go. Okay, I'm sure you could watch it letterbox if you really wanted to, but this is Math 40 6.6 Part 2, and we are factoring. Yeah, baby. Okay, so let's get into some factoring. Woohoo! First one up. Oh, isn't that beautiful? 7x to the 6th plus 28y squared. So the first thing we're always going to look for, always, let me remind you, is we're always going to look for the greatest common factors, or the GCF. So we got to figure out if there's anything that we see in both terms. So as I'm looking here, I see a 7 and a 28, and I realize 7 goes into 28 4 times. So I know I can factor out the 7. And then I wonder, is there anything else that's common between these? And I see that this has an x to the 6th and this has a y squared, but those don't have anything in common. So I'm going to go ahead and just factor out that 7. Remember that it's okay to factor out what you see. Like if you see something that's common, and you can always look inside and double check. And if there's anything else that's in common, you can just check that outside too. But these two have nothing more in common. So now we're going to go to the second step of factoring, which is to count the terms. There are 2 terms. So if there are 2 terms, then we've got the following possibilities. These are the patterns that we can recognize. Sum of squares, difference of squares, sum of cubes, difference of cubes, and possibly none of the above. So these have nothing in common. So let's see if we can figure out if these fall into one of these patterns so that we can, use the pattern to factor. I see that I've got a plus in the middle. So this is either going to be a sum of squares or sum of cubes if it's going to match anything. So let's take a look. So 2 terms and a plus means we might have sum of squares, excuse me, Sharktopus, or a sum of cubes. So let's take a look if we've got either of them. So I'm looking just at the x to the 6th plus 4y squared. So x to the 6th could be a cube or a square. What does that even mean? Well, x to the 6th could be x cubed squared, right? Because 3 times 2 is 6. But by that same token, and let me scooch this just a tiny teensy bit, I can also set it up as x square cube. So x to the 6th is a square and a cube. So it can go in either direction. It's very useful that way. Sometimes kind of frustrating because it's not obviously one or the other, so you got to check both. Now let's take a look at the 4y squared. Can I make the 4y squared into a square? Can it be rewritten as a square? And the answer is yes, it absolutely can be, because this 4 is a perfect square. 4y squared is 2y, the quantity squared. Take a look at that. Make sure you agree. Woohoo. But is it a cube? And the answer is, well, here's the thing. Math, there are many answers. Technically, I could write it as something cubed. However, it's not something nice, right? Y squared is not something cubed. 4 is not a perfect cube. Now, could I write something here? Yes, but it would be a mess and it would not be helpful. So when we're doing these problems and we're factoring and I'm saying, is it a square? Is it a cube? I'm using less precise language. It technically could be written, but it would be a mess and it wouldn't be helpful. So I think that what we're looking at is this pattern falls into a sum of two squares. At which point we celebrate, yay! It's prime. As long as they don't have anything in common, there are no more GCF, there are no more CFs at all, common factors, then what we've got left is prime. So now don't get so excited here because we got to go back up here and we say, okay, so for our final answer, we're going to factor out the 7, but the x to the 6th plus 4y squared does not fall into a pattern we know how to factor. Now, again, I feel like you all can handle the truth. I do think you can handle the truth. So I'm going to tell you that, this is a little teeny little lie. And sometimes when we say it cannot be factored, maybe there are other ways to factor it. So what I'm saying for reals is this is where we need to stop for Math 40. And, maybe if you study math for a few more years, maybe there are other ways to do things. But for right now, this is done. That's as far as we can go. Yay! Okay. Oh, sorry. I'm trying to be thoughtful about leaving time for screenshots and such. But remember that you can always get the copy of my notes as well. Okay, let's go on to the next one. Woohoo! Oh, you can't see it. Ta-da! Okay, again, whenever we're starting a factoring problem, the very first thing we're always going to look for is the GCF. Any common factors, let's get those out because it's going to make everything smaller, easier to work with. Woohoo! So I see 2x squared, I see 50a squared, and I see a minus 20ax. Now, I don't know about you, but personally, this makes my head swim a little bit because it's hard to see what's common because everything seems to be mixed together. So one way to do it is to write each of these out. Like we could do this. Now you may not want to, but you can. You don't have to. Let's see, 50 is, 2 times 25. I could go further than that. AA. And then minus, and then 20 is 2 times 10 AX. Now, why did I make a point of factoring out the 2? Well, I started to notice that there are 2's common in each term. Okay, so I can definitely pull out a 2, but can I pull out anything else? It looks like there's A's and X's everywhere. Let's look carefully. I've got two X's multiplied together here, just X's. So only X will come out of this term. Notice in this term, we've got just A's for variables, no X's. So do these two have any variables in common? And the answer is no, they do not. And then this one's everybody's friend, right? There are some people that just get along with everybody. They got a little A, they got a little X, everything is great. But they can't fix the whole group dynamic where these two really very little in common except for the 2. So we're going to do our best. We're going to factor out the 2 and see what we've got left and then see what we can do about factoring this. So let's see, I'm going to put it back together again. That's x squared. This is 25a squared. And then this one is minus, remember that minus, 10ax. Pardon me. Ooh, that's a good one. This is now 3 terms. And I see something interesting about it. I got a square and another square. And then the term that's the mix that's normally in the middle is on the end. So in other words, this is written in a really funny order. And I'm going to go ahead and rewrite it so I can see what's going on better. Now this is a more usual way to see a trinomial with the squares on the outside and then the mixture, the blend in the inside. And so I'm going to take a look at that and I'm going to see, okay, if there are no more common factors, then I go to my 3 terms. Sorry, I have to cover it up to look at it. 3 terms are either going to be trial and error or the AC method or a perfect square. So here are the perfect square formulas. And I want to go ahead and see if that perfect square formula is going to fit. So let's see if we've got the perfect square formula is going to be a squared. And again, let me bring it back up so you can see there are 2 of them. There's one that has a plus in the middle and there's one that has a minus in the middle. And I'm going to use the minus one. So a squared minus 2ab plus b squared. Does this fit? This is the perfect square. So this is the pattern we're looking for. Does this pattern fit this? And as I look at it, is the first term a perfect square? Yeah, this is. X squared is a perfect square of x. Is the last term a perfect square? Because it's got to be another square. And the question is 25 a perfect square? And the answer is yes, it's 5 squared. So that's going to work. And then we got to figure out, do I have in the middle what I need to fit this pattern? So let's see. Let me see. So I'm going to write this out again in the format. So x squared is x squared. And then the last term here is plus, and I've got to write it as a square, and that's going to be 5a. 5a, the quantity squared, gives me 25a squared. Okay, so I got that. That fits in there. And then the question is, do I have a negative 2, right? Because I have to have that 2. And then I have to have an a. The a is the first one. And I have to have a b. And the b is the second one. Do I have this in the middle? Does it fit? So I should have a 2, an x, a 5, and an a. So 2 times 5 is 10. So I should have 10xa or 10ax. It does. It matches. Yay! So we have a perfect square. Now, do you always have a perfect square? No, a lot of times, especially even though the first and the last work, a lot of times there are shenanigans in the middle and it doesn't quite fit. And if that's the case and you don't have a perfect square, then you're going to have to go through, and I feel like I should write trial and error / AC method. Let me write that down because it's one of the other options. And then also, I have a video that I haven't been able to post yet because YouTube and I are not getting along right now, but I hope to get it posted soon, and that's something called the X method. So we've got 3 possibilities here. If it's not a perfect square, then you go to one of these methods to factor. But in this case, we do have a perfect square. So the perfect square formula says if you've got a squared minus 2ab plus b squared, it factors as a minus b, the quantity squared. So since we've got this nice, beautiful little formula, I can write this as, so if I've got x squared minus 2 times x times 5a plus 5a squared, then I've got x minus 5a, the quantity squared. Now, what if you're looking at this going, this seems so easy, and I'm really nervous about this? Then you could always check. Let me scooch this up a little bit. We can always check x minus 5a, the quantity squared, is equal to x minus 5a, x minus 5a. I can use FOIL. First is going to be x times x. Outer, x times negative 5a. Inner, negative 5a times x. And then last is going to be positive 5a times 5a. So this is x squared minus 5ax minus 5ax plus 25a squared. X squared, can you still see? Yep, minus 10ax plus 25a squared. Does this match what's in here? It does, yay! Okay, now, with all the excitement, we've got a lot of stuff written here. What's our final answer? And I want to point out that all of this, pardon me, Godzilla, all of this was just factoring this part right here. So don't forget that 2. Let me use a little blue to, oh my goodness, Sharktopus. I know, sometimes that's how math makes you feel. It just knocks you right over. So what you want to do in your final answer is don't forget the 2, but then also write so inside the parentheses, we've got this. So we've got x minus 5a, the quantity squared, and this is our final answer. Wow, that was an exciting one. So much going on. A lot of people ask, do I have to write this much? And the answer is no. No, you don't. If you recognize the pattern up here, you could have been done with one more line. I put in all of this so that I am writing out my thoughts. Hopefully it's helpful in the notes. So because there are a few people who just use the notes, they don't also watch the videos. Okay, shall we go on? I think we've got a little bit of time. I'm not sure we're going to finish the whole set of problems, but let's give this one a try. Ooh, this one's a good, nice one. This one's nice and juicy. Okay, 12x squared minus 40x minus 32. A lot of people would jump right into trying to factor this, but again, you always want to check for common factors. And hopefully you find the greatest common factor, the biggest thing that goes into all of them. So let's see, I've got some x's and some numbers and some x's, just numbers. Okay, so x is not going to be common because it's not in all 3, but I do have numbers. They're all even, so I know I can factor out a 2. Can I factor out anything bigger than that? And the answer is yes. If you take a look, 12 is divisible by 4 and 3, and then 40, well, 4 goes into 40 for sure, and 4 also goes into 32. And I'll remind you that what you could do if you're not seeing this, if you're looking at this going, oh my gosh, I never would have seen that, that's okay. Remember, what we can do is when we're let's try GCF. What you can do is you can take the numbers, you don't have to worry about the signs to do this, and just start factoring. Let's see, 4 times 10, 2 times 2, 2 times 5. Just very quickly setting up some factor trees. 4 times 8, 2 times 2, 2 times 4, 2 times 2. Okay, so 12 is 3 times 2 times 2. 40 is 5 times 2 times 2 times 2. And 32 is a whack ton of 2s. 2 times 2 times 2 times 2 times 2. And remember, what you want to look for to find the greatest common factor is the most. You want to look for the most that fits into all of them. So I see a 3. There's no 3s in anything else, so that can't be it. And I see a 5 here, no 5 shared, nope. Okay, now in 12, all I have is 2 more 2s. So these have a bunch of 2s in common, but this guy only has 2 2s. So the most you can do is 2 2s in each, or in other words, 4. The GCF, I don't know why that's so hard to write. My hand thinks it's 2 C's. Is 2.2 times 2, which is 4. Woohoo, yay! Now, did you have to write all this out? No. Could you have just thought it in your head? Yes, absolutely. So I have got, 12x squared minus 40x minus 32, which I'm going to write as 4 times 3x squared, minus 4 times 10x, minus 4 times 8. There we go. And I've got 4 common in each term. Woohoo! Sorry, we're back. There was a temporary glitch with my computer. Apparently, a lot of factoring is not what my computer wanted to do today. So, but let's continue. We had just left our heroes and they had come up with a common factor, which means we had 4 times the quantity 3x squared minus 10x minus 8. So that is our new version of this wonderful trinomial. And then we're going to go to our list of formulas and say, okay, I've got 1, 2, 3 terms inside there. For 3 terms, we've got trial and error, AC method, X method, or we've got the perfect square. And the last one that we did with the perfect square was actually really easy. So let's check. Do we have a perfect square? So we look at 3x squared. Is that equal to something squared? And we look at negative 8. Is that equal to something squared? And we look at those two and we go, oh, no. Okay, so next up, we're going to try. And then you've either got trial and error, AC method, or the X method. And hopefully within the time that it takes me to get this video up, the X method video will be, YouTube will let it out of its clutches. Right now it is languishing in YouTube. I don't know, the catacombs below YouTube somewhere. So hopefully they let it out. And then I'll be able to show you the X method too. So I need a new piece of paper. Woohoo. Now for this one, we write 5 continued so I don't get lost. And I've got 4 times 3x squared minus 10x minus 8. And I thought for this one, why don't we go ahead and use trial and error? This is the old original, back when I was a small child in the 1300s. This is all we had, really. In fact, we didn't have a lot of algebra, and I may be misremembering that we had even trial and error. It could be that we just had sticks and rocks and weren't allowed to think about the planets. So here's trial and error, the oldest, slowest, most successful. This will always work. This will always work. So, but it is, I think, probably the slowest method. So I'm going to take 3x squared minus 10x minus 8. Now, I just spent 30 seconds telling you that this is the slowest method. So why the heck am I showing you this? Well, this is kind of controversial among math teachers who tend to be, hundreds of years old. You've probably noticed. And so we talk a lot. Believe it or not, we spend a lot of time talking about how we should teach things and what's the most useful and what are we doing with our lives. And oh my goodness, how do we live on so little money? And all those fun things that math teachers talk about. And the reason that trial and error is a favorite and is for some teachers the only method they teach is because if you practice this method, it'll give you practice with getting them in your head. So you can get to the point where I can factor this in my head. The other methods are faster, but they don't get you that practice. So it's the difference between, if you want to get good at running, you can either practice running every day or you could pay someone else to practice running and they would get really good at running, but you would never get better at running, if that makes any sense. It would be a lot easier to pay someone else to go jogging for you. I'm actually thinking this is a great idea. And then I could honestly tell my doctor, oh yes, someone jogged 5 miles last week. Okay, so back here, I got 3x squared and I've got negative 8. You always start at the ends for trial and error. And for 3x squared, 3 is prime, so it only breaks up as 3x and x. You always have an x in each, and then you break up the numbers. Now, if this had been something like 15 or 24, I'd have a lot more options. But this one is just 3x and x. 3 only breaks up as 3 times 1, so we're done there. Now, over here, -8. -8 is a bit more of a pain because it's negative. So let's talk about the ways we can set this up. I could have 8 times -1, or I could have -1 times 8. I could have -8 times 1, or I could have 1 times, -8. So in fact, just breaking it up as 8 times 1, I can have 8 and -1 in one of two orders, or I could have 8 be the -1. Sorry, that was a bit of a pun. 8 could be the one that is negative. This isn't working. English, oh my gosh, it fails me sometimes. But we can also break 8 down into 4 times 2. So I could do 4 times -2, and then I flip the order, -2 times 4, or -4 times 2, and 2 times -4. So in fact, I've got 1, 2, 3, 4, 5, 6, 7, 8, 8 possibilities. Uh-oh. This is one of those I didn't plan ahead moments. Okay, so how do we do trial and error? Well, this is the moment where you probably want to speed up YouTube, because I'm going to write these all out. And I should, if I were a really great YouTuber, I'd know how to speed this up and put like funny music to it. You just have to imagine the funny music. So those are the 1s and the 8s. I'm doing these, I'm going across like this. So this is all 4 of those. And then I've got 3x plus 4, x minus 2, 3x minus 2, x plus 4, 3x minus 4, x plus 2, 3x plus 2, x minus 4. So again, this is not a fast method. What you're doing is you're working through and writing out all the different possibilities. These are all the ways to break down 3 and -8. And so if you multiply these all out, pardon me. So for example, using FOIL, I've got 3x, so this is 3x squared minus 3x plus 8x minus 8, which is 3x squared plus 5x. Oh my goodness, that's not mine. That's not plus 8. What was I thinking? Hello. Oh no, it is. Okay. Minus 8. Sorry, I misread my own work. I was about to bring in the white tape of destiny, but I'm going to put that aside. Is that the number we're looking for? 3, no, I'm looking for a -10 in the middle. So what are we doing? Well, this process allows you to practice, so you'll get really good with FOIL because you're going to be foiling forever. But it also helps your brain practice working out what numbers, how numbers mix together, which is a really important part of math. So I'm actually going to skip a few instead of going through all of them, because I'm sure you would love to watch me put together a bunch of foils. But let's say we got all the way down to here, or I wrote these all out and I was like, hey, you know, I want to try this one down here. I get 3x squared plus 12x minus 2x minus 8, which is 3x squared plus 10x minus 8. And I look back up and I said, ooh, did I get it? And I see that I am very close. The difference is I got plus 10x instead of minus 10x. And so now I realize, oh, what I actually need to do here is I need this to switch to a minus, which means I need to take the -2 and make it a +2, and I need to make the +4 into a -4. So switch the signs. So if I come down here to 3x plus 2x minus 4, let's try that one. 3x squared minus 12x plus 2x minus 8, which is 3x squared minus 10x minus 8. Oh my gosh, we got it. Look at this. This is the correct one. And here's another possible problem when you get these problems that take so long to solve. Because at this point, I'm like, okay, there's the answer. I'm done. Life is good. And then if you sneak back up here and you remember, wait a minute. Oh, right, there was a 4 out in front. So you got to remember, double check. And I am going to do a big box right here where I'm going to write the 4 times the 3x plus 2 times the x minus 4. And in fact, I feel like drawing some colors on this. Ooh. Oh, sorry, I took you to Smearyland. Sorry about that. Did not mean to go to Smeary Town with you. And I'm going to write final answer here. And so I've incorporated the 3x plus 2, x minus 4. That's right there. And I've remembered that I have that 4 that should sit in front of it. And life is good. Woohoo! Yay! Okay, guys, we're going to have one more video because I've got 2 more problems to work out. And in the meantime, math on.